welcome back. You know now how to create a web server in order to monitor activity on your Arduino. This is quite useful for real-time monitoring where you want to know what is happening right now with your sensors. But what if you wish to keep historical records of your sensor readings so you can inspect them later? In that case, you need to somehow record these readings. Broadly speaking, there are two ways to do this. You can record readings on board the Arduino using an SD card reader or writer, or you can use an online service to which your Arduino can send its readings periodically, and from there you can use your web browser to monitor in real time, plot historical values on a chart, or download the data to your computer. There are a few really nice services that allow you to do that, and in this lecture we will look at Nimbits. Nimbits is a cloud service that allows you to log and retrieve data from all kinds of devices, from Arduinos and Raspberry Pis to web servers. Anything that generates data needing logging can use Nimbits. And did I mention that Nimbits is open source and free to use by the community? Another popular service is Xively, formerly known as Pachuba. Xively provides a variety of services, of which logging is just one. It has a different business model to Nimbits, and while it allows free use by developers, it does have limits that an active Arduino hacker could reach in no time. In the next lecture, we will also look at logging your sensor data to Twitter. Twitter is often used not so much as a logging service, and this would be a bit awkward, but for its social broadcasting and direct communication capabilities. If you'd like to expose environmental data to the whole world to access, then Twitter is for you. Or, if you want to receive a direct message as an alert when a sensor value exceeds a set limit, again you can use Twitter. The hardware for this demo requires the Arduino Ethernet shield, a photoresistor to use as the sensor, and the 10 kilo ohm resistor to use as a voltage divider with a photoresistor. Or feel free to use any other analog sensor you may have handy. As a logging service, Nimbits provides several benefits. It's managed, so you don't have to worry about maintaining it. It's free, supported by ads, with an option to purchase an account in exchange for an ad-free experience. You can download the software and host your own Nimbits server, so should your project requirements need a privately hosted logging service, and the Nimbits creators and maintainers actually can do this for you for a fee. This is an important future-proofing feature that significantly safeguards your time investment to this technology. Nimbits also offers that every new record is time-stamped, which means that your Arduino does not need to maintain a clock. Arduino doesn't have the hardware required for real clock and timekeeping, but there are breakout boards that you can use for this purpose, but they do add complexity to the project. Finally, Nimbits uses a simple HTTP interface, which means that your Arduino can talk to Nimbits without any special libraries. So let's get started. So in this demo, what I'll do is use this Ethernet shield for the Arduino. I'm going to use it to log data coming out of this photoresistor into an online logging service, and the one that I use for this demo is called Nimbits. If we go to the Nimbits website, we'll see a little bit of information about it. It's a really good service, it's free and open source. The really nice thing about this service, other than the fact that it does what it advertises, is that you can download its code from GitHub. So if you go to github.com and search for Nimbits, there you go, you'll find it. You can then download this software onto your own server if your requirements change over time and you need to have this service hosted on your own hardware so that you can control it and just run it. And that's really good security, future-proofing your projects. So first, we're going to create an account on Nimbits. Then we're going to use credentials that we create with this account to configure our script so that the data from the Arduino that runs this script ends up in our Nimbits account, and from there we'll be able to also plot it and collect the data so that we can download it perhaps and pass it through perhaps Excel and do a bit of analysis on it. So let's go ahead and log in, and to do that I'm going to use my existing Google account. So password. And now we'll allow Nimbits access to my account. Alright, so this is a fresh account, there's nothing in it. So the first thing I've got to do is to create data points. So one sensor will be sending its data to a single data point. If I have two sensors that I want to record from, then I'll have to create two data points on Nimbits, and so on. So to create a data point, I select my account email address and then right click on it and select new data point. So I'll give it a name. I call it DP1 for data point 1. I'll create another one, call it DP2 and hit OK. The data points are ready, but one more thing that I need to do is to create a key, because my Arduino sketch will need a key to be able to authenticate its post requests with Nimbits. So again, I will right click on my email and just choose new read write key. In here, just press some random numbers. All these together make up my key. And to keep things simple, I'll select read write to all points, and I can alternatively restrict read write to a particular single point, data point. I'll keep it simple for now and just choose this option. You should really experiment with the rest, and that way you'll be able to add up some more security to your feeds. So submit that and done. So that's really all I have to do here. Now if I double click on, say, this data point, then I get a plot of the existing data. Of course, there's nothing to display at the moment. I haven't posted anything, but this is going to be soon populated with data points, and those will be charted. So before I continue, I need to copy this key, and I'll put it in a text file so that I can reuse it later, but you need this key, so I'll keep it handy.